Okay, it's 15. Welcome to today's ASK Online Academy webinar on reclaimed sound quality and its impact on callbox resin performance. I am Pierre Vasley, the business line manager for callbox resin for ASK Chemicals in Europe. The webinar will be presented by Frank Lenson, a technical product manager for callbox resin in Europe. Frank has over 30 years experience in the foundry callbox binder development, including 8 years with ASK. He will explain the main factors of sound pollutions that can impact on the performance of a callbox system, detailing the orders of magnitude to be taken into account. Before we begin the webinar, we have a few organizational notes here. For data protection reasons, no clear names are visible. The image and camera transmission is also deactivated. You can submit your question via the chat function box at the bottom right of your screen. We will, of course, try to answer them afterwards. Questions that we are unable to answer in the webinar will be addressed by our expert afterwards. The presentation will last around 20 minutes and will reserve around 10 minutes for any question you may have. So, I'd like now to hand over to Frank and wish you all a good listening experience.
So thank you, Pierre, for the nice introduction. Let me also welcome you to this webinar. And I'll try to help you the next 20 minutes to find a way to the theme reclamation system. So first of all, you see here an agenda, and you see the themes we are discussing, or I present. So first one is, so why do we need reclaiming sand, and what sense make it to use it? Second is a general procedure for sand. What quality is important for common sand? And then based on this information, we would like to look a little bit closer to the reclaimed sand and the impurities from the process, which have an influence to the strength behavior in the process of callbox. And then I would like to talk a little bit about new market trends and our solutions to support you to use more sand, reclaimed sand in the future. And finally, the conclusions. So let's start. Why do we need reclaimed sand? What is it used for? For sure, we have worldwide the same situation. The raw materials are, the prices are increasing. And with the raw material prices, also the transport costs are increasing. So this is a very strong driver for reduce raw material, using less raw materials and reducing transport costs. On the other side, we have this deposit situation in Europe. We have only a small number of abilities to deposit waste sand. And so here also the price is increasing permanently. And also the sustainability must be improved. All of you know the CO2 theme, CO2 footprint, and we all try to get a little bit more sustainable in our processes. On one side, we have these cost perspectives and deposit perspective. On the other side, we have also technical reasons, because the already heated and heat-treated sands has benefits, because this typical sand expansion defect is not showing, or it was reduced by using the reclaimed sand already. So you can use the reclaimed sand also against the veining tendency. So we are finally getting better casting results in the best case. So the next two slides are only for documentation, especially for the US people. And so there are coming graphs, and here in the next slides, this one and also the next one, the method is described, how these test bars are made. I know that you have in US a different system, so that you have an idea why the values or the numbers may be a little bit different than yours. So this is only for the documentation. So let's look at the general sand parameters. So first of all, when you use sand, fresh sand, also here you have parameters to look at. And let me discuss about a few and their influence to the quality of the core. We have here the first parameter, which is the pH value. So the green line over time means you're making a fresh sand mixture stored in the sand bunker of a machine. And then over time, you use this sand mixture, and you see with the green line, so a more or less neutral pH, you have not a big influence over time. But if you have strong alkaline sands, like shown here in the yellow line, this has a significant influence. So the more alkalinity you have, the worse it is for sand, because the bench life is reduced, significantly reduced. So pH, you have always to look at a neutral pH when you look at the pure sand. So next parameter is then the water content. We are talking about, especially here, about cold box. Cold box, we have two parts. The second part is based on isocyanate. Isocyanate is a very strong reacting partner, especially for OH-containing contents like water. So the reaction is quite fast. And same here, you see the green line, so we have no water in, and you have no big influence on the bench life. With even lowest value of water you add, you can see the effect, because water is reacting with the isocyanate, and this will reduce the ratio between PAR 1, PAR 2, and significantly also the bench life. So you have to prevent in your whole process that water is coming into the system. Shooting air must be dry, sand must be dry. Also the venting from the part 2, which is usually made with passing silica gel, you have to take care that this is all working well. So water is a quite important point here. So next parameter is dust. You see that the dust is also, when we are below 1%, or above 1% of the fines here, 0.063, which is the sieve, which is described here. If you're below 1%, everything is fine. If you're above 1%, you have much more surface, you have different gas permeability, so you're losing strength. Next parameter is the temperature. Also here we have the situation that, like all chemical reactions, they're sensitive to temperature. The lower the temperature is, the slower the reaction is. So you have to temper your quiescent to appropriate conditions. 20 degrees is recommended from us. So now let's switch to the reclaimed sand, and let's look at the impurities you have in your sand system if you reclaim your sand, and the effect on the sand itself. So what have we done here? We have made a case study. We have taken 50 sand samples from a customer out of the process and made a lot of analysis of these sand samples. So you can see here parameters, mechanical parameters, but also strength tests we did with every of those 50 sand samples. And on the right side, you see a diagram of one parameter, which is the conductivity. And you see the variation, the normal, typical variation in the process of this customer. So each dot is a point. We've measured all these parameters. Next point was then to find out how are the parameters correlating. So what is happening with the strength if the pH is going up or down. Same with conductivity. So we have then finally a diagram which is looking like this one here. So you don't have to read the whole diagram. I only want to explain you what we've done, and that there's a lot of data behind. So you see red and blue and white squares. A red square, or in this case, sorry, a blue square here means you have here the initial strength after 15 minutes, and here the conductivity. This means the higher the conductivity is, the lower the strength will be. This is indicated by the blue squares. The red squares, all the way around, the higher the strength here, the higher the bench life will be. So there's a direct correlation. In this case, a positive correlation. So you have to look only at the squares which are colored. This is only to give you an impression what we've all tested and where we found correlations and where not. So you see here fines at AFS, there's no color here. So in our cases, the 50 samples showed not a significant correlation between fines and AFS in corresponding to the strengths. For sure, you can expect when you increase fines to a high level, you will have an influence, but the fines of all samples here were so low that there was not a significant influence we could see. So next parameter here, this is again based on the conductivity. So we have here the scale from conductivity from 78 to 505. So values we measured from those 50 samples. And on the y-x, you see the strength level. And here easily you can see if you increase the conductivity, the strength level will drop significantly. We're starting here at 200 Newton per square centimeter, and here we are only at 120. So this is a significant correlation between conductivity and strength. Even more, you can see the colors here. The colors are indicating the pH value, which means blue is a low pH and red is a high pH. Again, more or less in the red area you have low strength, in the blue area you have high strength. So lower pH is good, higher pH is bad. Again, a correlation. So this is part of the summaries we've made and we found. So our main parameters we could see which have an influence to the sand quality of reclaimed sand is conductivity, pH, and LOI. Here we have a negative and a very high impact to the strengths. A positive or low impact in our case, based on the 50 samples, are the fines and AFS. Again, this is mainly due to the fact that the fines of all the 50 samples were quite low. Okay, so it's the first small result. Then the second question we asked is what is causing this high pH and conductivity? What is the reason for those parameters changing from one sample to the next? So we analyzed further those 50 samples to all these elements, silicon, aluminum, and all the other elements to look if you find a correlation between concentration of those elements and the pH, conductivity, and strength behavior. And again, we have this diagram here, same way to read it. Let's look at the sodium here. Sodium is a blue square, which means the higher the sodium concentration, the lower the strength will be. So this is indicating that it's not a good element, quite easy. On the other side, iron or chrome, you see that the color is fading, nearly white, so the influence is much smaller. On the other side, you have here the red square, so high sodium concentration means also high conductivity. So there's a significant correlation you can write here. So what we found is that based on the first experiment, and here we have the second, that the highest effect on the strength, on the quality of reclaimed sand is potassium, sodium, calcium, sulfur, and aluminium. Here we have a highly negative effect. So if the concentration of those parameters is high, you will have problems with your quality of reclaimed sand. On the other side, we have also parameters which are not playing a big role. Chrome, iron, titan, phosphor are not playing a big role in this case. So let's look a little bit closer about the behavior of the concentration and strengths. Here we have, again, the elements which shown a big effect to the reclaim system. And you see, for example, sulfur here, it's a logarithmic scale. The concentration of already 0.1% reduces the strength from 190 to 130. The same with the potassium. Calcium is a little bit not so intense in the effect, and the lowest effect has aluminium. And here is meant not metal or elemental aluminium. It's always the soluble form of these elements. So the question then, okay, where are these elements are coming from? And here we found that sulfur and potassium and also calcium are mainly coming from the riser, from bentonites, so from the green sand side, and also from the water which is used. In our case, there was a lot of agriculture in the surrounding of the foundry, so the fertilizers showed up in the used water. But usually in the foundry, you're not able to measure all these elements from your sand samples. So how can we maybe correlate these elements and the concentration to a little bit easier to measure parameters? And here we have this correlation. We found that you can measure with a pH value and also the conductivity. You can predict somehow the concentration of the elements. At least you can predict the effect of the value to the quality of the sand. So here you can see again the blue line. I think I have it a little bit bigger on the next slide. So the blue line with the pH coming from sulfur with a low concentration, you have a low pH. With a higher concentration, the pH is increasing. So as we've seen on the slide before, sulfur has a big influence. You can see that sulfur also measurable with as a summary of value with a pH value. The same with the conductivity. So what have we learned here? You can use the pH value and the conductivity as a very good parameter to predict the quality of the reclaimed sands, because these parameters allowing you prediction of impurities. So let's look at this diagram. This is again the pH of the 50 samples we've taken, but now correlated with a bench life of 3 hours and the final strength after 24 hours. Means the sand is stored in a sand bunker at the machine for 3 hours. Test bars have been made, and those test bars have been tested after 24 hours. And here you can see that there is pH which can be accepted from the binder system. Here we have 9.3. If you increase the pH above this 9.3, then you lose strength. And here ASK can help. We can adjust this point depending on the quality of your reclaimed sand. So again, pH value and conductivity are very good control parameters. As I said, we are able to help you from ASK side by adapting our binder systems to your conditions, but also here we have limits, especially when you have changing qualities. So one of the targets using reclaimed sand is to have a constant quality. Not discussing about the pH and conductivity level, but you have to have a constant conditions, because then we are able to help you with the binder system. If you have big variations, this cannot be compensated by the binder. And hereby you're able to reuse the green sand in the process. If we have stable processes, we can potentially compensate. So let's talk about market trends. We have a lot of different suppliers on the market for reclaiming systems, thermal, mechanical, but there are also in this area developments every year. So the suppliers are trying to improve themselves. And for example, there's a new solution on the market, secondary attrition technology. Um, this is mainly made for processes to reuse then green sand and also coal sand. So this technology works well. And yeah, but again, you cannot blind trust these systems. You have to control and you have to check your quality, especially the parameters I've talked about, to be able to adjust your system and to keep stable and constant quality. It's the only way to work in a good way, with a good quality, with the lowest addition levels with your reclaimed sand. Addition levels is the next point. So where can ASK help here? Let me talk about a case. We have a customer which has now implemented a new recycling system, and his question was, can you deliver a system which can work with a higher volume of reclaimed sand? So we compared the actual used system with one of our newest system, with in our case, EcoBlue Pro. So this is a diagram. Again, you don't have to read it completely, I explain it. So on the left, you have in blue the AG system, the common system they're using, pure sand, no reclaimed sand. And the further you go on the right, the more reclaimed sand is used. Here on the right, you have 100% reclaimed sand. The green system is a new one. And you see here at this point, blue system, 240 Newton per square centimeter, with a mixture of 40% reclaimed and 60% reference sand. The customer is working very well. So this is the blue bar here. The orange line is indicating their actual level of strength they usually work with. So as you can see here, if you use then EcoBlue Pro, we still have this 220 Newton per square centimeter. But with the green bar, we reach this orange line at 80% reclaimed sand and 20% reference sand. So we are able to increase significantly the amount of reclaimed sand we can use here with this change of binder system from HE system to Blue Pro system. So yeah, we're able to double the volume of the reclaimed sand system, of the reclaimed sand at the same strength level. And I think this is enormous, and this is a real example from a customer, it's not a lab trial. So again, this is the way ASK can help you. We can adapt to your system, our binder systems. So recommendation. So first of all, you should use modern reclamation systems. If you start with a reclamation, look around what is on the markets. There are quite good systems. But again, you have to be in mind, or have to have in mind that you have also to control and monitor the parameters to define the quality of your sand. If you have this constant quality with modern equipment, we can adapt the binder system to your sand and to your conductivity in limits. Again, if you have pH significantly above 10, we are not able to compensate with the binders. So you have to have, let's say 9.4, 9.3, 9.5. This can be adjusted. It's not preferred, but we can adjust it. So that you have finally a good quality in production. And please keep in mind, here are also coming new regulations on the emission side. So the target must be reducing the binder level to a minimum. And here we can help in combination with a good reclamation system, in combination with a good binder system under constant sand quality conditions. So conclusion. So on one side, you've learned parameters are quite important. You have a first idea which parameters are very sensitive. You have to look at. You have now the ability to control by knowing the values. You can also change, let's say, dedusting or um, increasing the reclamation, the mechanical treatment, or adjusting temperature to see with the parameters where is your quality of sand moving. With this information, you get stable core production. And also here we have this optional binder adaptation to improve your process. Next point is then the cost side for sure. We have less process cost because if the process is running more stable, less core breakage, better quality, all these parameters are cost sensitive. We have less rework. Again, the reclaimed sand is a quality sand. If you have a good reclamation system, so it works for again anti-veining, and we have also the ability to, if you have here a good process, to have a high productivity. Sustainability I've talked about. Again, this reduction of emission will be more and more important. We have new regulations coming up. You have to be aware of this. The energy consumption will be significantly lower because if you have less core breakage, this will also have an influence to the energy consumption. CO2 footprint will be better, and we have less waste to throw away. So a lot of positive effects on the environmental side. So, and I think this team is worldwide active. Again, we have about 200, a little bit more, participants in this webinar. So it's worldwide of interest to work here in the reclaiming systems. So I'm done for today. And if you have questions,
yeah, thank you, Frank. Thank you for that presentation. And we'll now take a few questions already asked in the chat. So I have the first question: what is the best reclamation system, mechanical or thermal?
It's a hard question to answer because it's depending. We've talked about cold box. There are a lot of different systems on the market. Thermal, I know thermal reclaimed sand from customers which have better quality than the silica sand which have put in the process. So it's depending again how you handle this, and there's no preference. I think you have to look at your process and the cost you want to invest. And for sure, thermal systems have also a negative influence on the CO2 footprint because you have to burn, you have to use gas for the heat treatment. So you have to also have this in mind.
Okay, thank you. Another question: what instrument is used to measure conductivity of sand?
Yeah, there's you can buy it on the market. So there is some pH conductivity tester. It's not very expensive. Let's say 2,500 to 3,000 euro. This is not the point. The point is that you use that you prepare your sample quite well. So there are several ways of preparing those samples: cooking, cooling down, mixing, breaking the sand. So there are different rules on the market, and also here before you start comparing values, you have to define the method. This is very important. So conditions of preparing is here the issue.
Thank you. Another question. Additionally, if the pH is found out of range, what countermeasures should be taken?
Sorry.
If the pH is found out of range, what countermeasures should be taken?
Yeah, now you know that bentonite maybe, for example, can influence negatively the pH. So you know now the amount of the riser is one of those issues. Bentonite is one of those issues. So the reducing the impurities in your sand system is one way. Second is reducing the dust levels, because the dust is usually the substance which is highly containing the high pH materials. So dedusting is one of the key things here. Yeah, and then also diluting is another point. It's
Okay.
not hard to answer because there are several different reclamation systems on the market. And yes, pH is not good. That was what we learned today. To influence your system, your specific system, we have to discuss and to have a look at. We are open for your contact. If you have questions, don't hesitate. Contact me, and if I
Yeah,
can answer, I will.
I think there are plenty of questions, but I think we are at the end of a time. So for those who can and want to, I suggest to continue the discussion for another 10 or maybe 15 minutes. For those who have to leave now, I would like to thank you on behalf of ASK for your interest and hope to see you again at the next webinar. And I invite you to visit a website where you can find other information such as a product finder, the presentation and technical article. You will also find from tomorrow morning the recording of this webinar. And I also invite you to subscribe to our newsletter to keep up to date with the latest news of the company. Thank you for your interest. So for the other, for those who can stay in this online, we will take some other question. I'm not sure that we can answer everything, but we will try. So next question. How high is the reuse rate for reclaimed sand?
Yeah, again, this is depending on what you're intending to do. Do you reclaim the core sand, more or less pure, so getting rid of all the organic on the sand, or you want to have the green sand used as a core sand? So it's depending on the quality of reclamation you have, thermal, mechanical. And again, in some cases, like the case I showed, we're able to run up to 80% even using coming from a green sand impurity, so which is not good for Colbox. Again, 80% maybe is a limit, but maybe not. It's depending on your system. It's also possible that we in some cases get higher to 90-95%. But again, this is basically possible if you use more or less pure sand, not green sand. Impurities of green sand will be more complicated to handle.
Thank you. Next question. Is the EcoCure Blue Pro standard binder system, or are you able to make some changes that depend on the customer's reclaimed sand properties?
Yes, as I said, so we have this standard qualities already in the portfolio. which we usually start with, and then we have to look at your process and typical quality you have on your foundry. And yes, we are able to adapt also our binder system, as I explained, to your conditions. But essential is the stability of your conditions. If you have on one day pH 7 and the next you have pH 10, there's no binder on this world can compensate this. If you have constantly a stable quality pH 9, yes, we can adapt this binder that it works well with your sand system.
Thank you. Next one. Um, what is allowable limits of pH and conductivity and other parameters?
The limits, yeah, as I said, is depending. So the pH 10, let's say, is a soft limit for the pH. I would say above 10, it makes no sense. The example I showed, I can open this slide again, is 9.3. This is what we adjusted here. As you can see, above 9.3, the bench life is dropping. So depending, again, your system, we have to analyze your conditions, we have to look at your parameters, and then we have to define, yes, we can adapt, or it's too much. In this case, let's say 9.9, we have only 150 newton per square meter. If your process accept, so your cores accept 150 newton, you can work also with this one here. But in this case, we need 300. So for this customer, this level, the strength level is not acceptable.
Thank you. Next one. Is there any online monitoring system for reclaimed sand?
I've heard rumors about an online system, but I've not seen one. So there must be some online pH for sand. I don't know the principle, but I've heard rumors about this, yes. So it's not standard. Maybe it's a new development. We have to search for this.
Thank you. Next one is acid demand value checks not important, just pH.
No, acid demand value is also a parameter you can use. You have to look at the sand system. Here we have a more or less pH neutral binder with an impurity which is shifting the pH to alkaline conditions by risers or bentonites. You have also systems which are basically alkaline, and you're using alkaline sand. In this case, it's different. You have different behavior in the reclamation process, and also the furane resins, which are more on the acid side of the pH scale. So now today we've only discussed about cold box, and here the parameters I showed are easy to measure, and ADV is not relevant to define the conditions of the sand. pH and conductivity is enough.
Thank you, Frank. How often to measure pH and conductivity? Every shift, daily, weekly?
Depending on your process. Again, if you have stable process, you're taking continuously sands in your production process. If you have production problems because of low strengths, then the number of tests must be increased. If you have learned that you have more or less stable conditions, you can increase the measuring cycle. So we have this customer here, which is doing, I think, 5-6 tests over the day to check if the reclaimed sand is still in the limits. And one other option, if you're outside the limits, you can increase the binder. It's not the target, but it's also a way to compensate bad sand quality. Finally, the quality of your core and the quality of your casting is important. And you're doing everything to prevent problems in your production. Core breakage is not nice. If you have a constant production, it's disturbing. So knowing that your sand quality is bad, you have some toolings for working against binder addition. You can also dilute sand. You can take care of the impurities because now you know the impurities. So different ways to handle this.
Thank you, Frank. So I saw that there are a lot of questions about the other foundry process like no-bake and 3D and so on. So we will not take this question online, but we will answer afterwards for sure. So we will only take one last question, and then all the other questions will be answered by Frank afterwards per email, and I invite you also to contact him directly per email or phone. So the last question will be, how dust reduce binding?
Again, dust is increasing the area, so the surface area. And if you have high dust levels, this will consume binder. So if you have consumed binder, this will lead to lower strength at the same binder level. So you have to compensate with higher addition levels. On the other side, you can expect changes in the gas permeability. So higher dust levels will reduce the gas permeability, which increases then gas defect tendency. So dust level is quite a problem in general for sand quality, not only for reclaimed sand.
Okay, so I think that we are at the end of the webinar today. So thank you again all for your attention, and remember to visit us on our website and to subscribe also the newsletter. Thanks again. Enjoy your day, and see you next time in a webinar with ASK.
Thank you also
Bye.
from my side. Bye bye.